Good morning, class. Today we are going to learn how to graph an absolute value inequality in two variables on a coordinate plane. It's not going to be very different from what we did yesterday where we graphed an absolute value function on the coordinate plane, but today we need to introduce the shading for the inequality, and we need to recall when to use the dotted or solid line. The steps that we need to take for graphing an inequality on a coordinate plane are no different than graphing an equation to start with. The first thing I want to do is graph the inequality by finding its vertex and making a table of values. Remember from yesterday that the equation was y equals a times the absolute value of the quantity of x minus h plus k. And from that, we could pull out our vertex, which was just the point hk. Once I've plotted my points for my table of values, if I have less than or greater than, I'm going to use a dashed line. And if we have less than or equal to or greater than or equal to, we will use a solid line to connect the points. My final step is to determine where to shade. So I'm either going to shade everywhere inside or outside of the V-shaped graph. There's two ways that I could do this. If I have less than or equal to, I could shade everything that is below the curve. For greater than or equal to, I could shade everything above the curve. And if this doesn't work for you, the other method is to use a test point to determine which area to shade. So when you choose your test point, either choose a point that is inside or outside of the V part of the graph, and we're going to shade the half that has the solutions in it, and that is called our solution region. So when we use the test point, if we get a true statement, we would shade the part that contains the point, and a false statement, the part that does not contain the point. Please take a moment to pause the video and make sure you have recorded the steps in your notes. Now let's look at a few examples together. For the first example, we're going to look at the inequality. Y is greater than the absolute value of the quantity of x minus 2 plus 3. Starting off, I'm going to identify my vertex. Inside the absolute value symbol, I see x minus 2, which means the x value of my vertex is 2. And at the end, my k value is 3. Now that I have my vertex, I'm going to start making my table of values. As always, that vertex goes directly in the center. And then I'm going to choose 4 other x values to finish filling out my table. So since I have 2, I'm going to choose 1 and 0, as well as 3 and 4. Remember, in the end, we only need to plug in 2 of the 4 values because of the symmetry. I know that 0 and 4 and 1 and 3 are going to end up having the same y values. So when I substitute in, let's start with 0. I have the absolute value of the quantity of 0 minus 2 plus 3. The absolute value, or 0 minus 2 is negative 2. So I have the absolute value of negative 2 plus 3, which is 2 plus 3, or 5. So I also know that I have the point 4, 5. Then if I plug in 1 for my x value, I'm going to have the absolute value of 1 minus 2 plus 3. 1 minus 2 is negative 1. The absolute value of negative 1 is 1, and 1 plus 3 gives me 4. So I'm going to take a moment and plot these 5 points on my coordinate plane. Now that I've plotted my points, I'm going to go back and look at my inequality. My inequality says that y is greater than the absolute value of the quantity of x minus 2 plus 3. Since it's only greater than, I know I'm going to have a dashed line. So I'm going to go ahead and connect my points with a dashed line. And it's important when we do this that we make sure that our line goes completely through the entire coordinate plane so that I can shade either inside or outside of my V afterwards. If I decide to use a test point for determining where to shade, the easiest point is always to use 0, 0, which at this point, if we look, the point 0, 0 is outside of my V-shaped graph. If I plug in 0, 0, we'd have 0 is greater than the absolute value of 0 minus 2 plus 3. So 0 is greater than, we've already done that calculation and figured out it's 5. 0 is not greater than 5, it is false, which means that that point is not a solution. So I'm going to shade everything inside of the V, and that would complete my graph. If it had worked out to be a true statement, then I would have shaded everything that contained that 0, 0, and that would have been everything outside of my V. Please take a moment to pause this video and record the example. Now let's look at another example together. I have the inequality y is less than or equal to negative 2 times the absolute value of the quantity of x plus 3 plus 5. Inside the absolute value symbol, I see x plus 3. Since my vertex is supposed to be x minus h, and I see addition, it means I was subtracting a negative, so my h value is negative 3. My k value on the end is 5, so my vertex is the point negative 3, 5. When I start making my table, I'm going to put that directly in the center, and then I'm going to choose 2 values to the left and right of that. So negative 2, negative 1, negative 4, and negative 5. Remember again, we only need to plug in 2 of these quantities because of the symmetry. Negative 1 and negative 5 will have the same y value, and negative 2 and negative 4 will have the same y value. Now that I know the other values that I need to plug in my table, I'm going to start plugging them in and doing the math out. So if I plug in negative 1, I have negative 2 times the absolute value of negative 1 plus 3 plus 5. Negative 1 plus 3 is 2. The absolute value of 2 is still 2, but I need to multiply by the negative 2 out in front to get negative 4 plus 5, which gives me a value of 1. So I have my point negative 1, 1, and I also have negative 5, 1. Now if I plug in negative 2 for x, I get negative 2 times the absolute value of negative 2 plus 3 plus 5. Negative 2 plus 3 is 1. The absolute value of 1 is still 1, times the negative 2 in front gives me negative 2. Negative 2 plus 5 gives me a y value of 3. And I also know that I would have negative 4, 3 as well. Now that I've completed my table, I'm going to go ahead and plot my points. Now that I've plotted my points, I need to go back to my inequality, and I see less than or equal to. Since it has the equal to with it, it means it's going to be a solid line. So I'm going to connect my points, making my V with a solid line. Please make sure that when you draw it to extend your V through the entire coordinate plane, so when you shade either inside or outside of the V, you can clearly see where the shading is. Now, since my inequality that I have is less than, I can use the shortcut and say that since it's less than, I would shade below the curve. In this case, everything below the curve would be inside of the V. So I'm going to shade inside of my V, and that would complete my graph. If it was above the curve in this case, I would have shaded outside of the V. Please take a moment to pause the video and record the example. Now that we've done 2 together, please take a moment to try this one on your own. Pause the video to try it, and after you've completed trying it on your own, please resume the video to check your answer. Looking at this example here, my vertex is the point -1, -3. When I put that in the table and I choose my other x values, -3, -2, 0, and 1, I then go and plug in 2 of my x values to finish my table, remembering that -3 and 1 and -2 and 0 will have the same y values because of the symmetry of the graph. If I plug in 0, 0 plus 1 is 1, the absolute value of 1 is 1, minus 3 gives me -2. So I have 0, -2, and -2, -2. Then if I plug in 1, 1 plus 1 is 2, the absolute value of 2 is 2, minus 3 gives me -1, so I have my point 1, -1, and 3, -1. So then I plot my points, and since I have greater than, I would use a dashed line, and again, since it is greater than, I would shade above the curve, and everything above my curve would be everything inside of the V this time. If I had chosen to use a test point and I used my point 0, 0, I would have gotten 0 is greater than -2, which is a true statement. So I would have shaded inside the V because inside the V is where the point 0, 0 is contained. When you have finished copying your notes, please go up and see the sub to get a copy of today's assignment and work on that for the rest of class. If you finish your assignment, there is also a booklet posted for additional review. Have a great weekend. I'll see you guys on Monday.